Hello, we are Mariana, Ami, and Marco, and we are presenting study case 2. In general terms, for this case study, we needed to analyze information and develop a system that could make the most optimal schedule. For this, we had some assumptions that are, we had a forecast of 12 weeks, 5 parts, 5 machines, and 1 part can be done in more than 1 machine. Also, we have an available overtime per machine of 48 hours, and this needs to be reduced. We have the setup time for well done once a week and a yield factor. Next. For this, we have 2 key questions. That is, what is the optimal production schedule if the company is not allowed to carry inventory, and if it's possible to meet the demand with this. For this, we have some parameters that we can see here. We have 3 sets: part, weeks, and machines. We have a demand, a yield, that is the percentage of acceptance, a setup time, a production time, and a table of incompatibility for the setup time. We have some variables, which is the X, if it's chosen or not the machine, the P, which is the maximum production, the R, if it's the approved production respecting the yield, the O, which is the shortage units, and the W, which is the overtime.
For this case, the objective function of the model seeks to minimize the shortage units, as well as minimizing the overtime. In order to achieve this, the program will first use up the 120 hours available on weekdays in all machines, and only when it is reached, it will grant overtime hours to the most efficient machines. It is important to say that a high coefficient was added to the shortage units to cause the linear program to prioritize the minimization of shortage units. This is the optimal production schedule for 5 parts for 12 weeks. Since the values are not equal to the forecasted demand, it is not possible to meet all the demand. According to the shortage units, there was a lack of 100.132 units of part 1 and 1,078.571 units of part 2 during week 11. Regarding the overtime chart, it shows the extra number of hours needed to meet the forecast. Since overtime can be only used during weekends, a maximum of 48 hours additional to the weekdays are available for each machine to operate. Those machines having no overtime work exactly 120 hours. During week 11, the maximum overtime is used in all machines. This means that the week 11 is the one having the greatest demand, and explains the fact of not meeting all required units during week 11 for part 1 and for part 2.
For this next case, we have a different policy, which is now we can have inventory. And is it possible to meet the demand with this inventory? We have the same information for the parameters. We just add 1 variable that is in the next slide, which represents the extra units stored in the inventory.
The model for case B is exactly the same as in case A, except for the addition of the variable of the inventory A. This variable is added in the objective function in the minimization, since we want the least amount of inventory, thus having the least surplus as possible and only having units in inventory when necessary. This variable can also be seen in the second constraint, where the addition of the production plus the shortage units plus the inventory must meet the demand. If this addition is greater than the demand, then the excess units will be stored for inventory of the next week, which is AJ+1I. The solution for this model can be seen in the following table, where all the units of the demand met is exactly the same as in case A, except for week 10 in parts 1 and 2. These 2 values are actually greater than the demand, which means that there is an overproduction. These extra units are those coinciding with the shortage units of the previous model. These extra units are then going to be stored in inventory for week 11. This can be seen in the variable of A shown in the screen. Then all demand is met. This also is reaffirmed for the shortage variable O, where we can see that All values are equal to 0 for all parts for all weeks. Therefore, all demand is met since there is no missing units. Now for the overtime, all the values are exactly the same as in case A, except for week 10 in machines 1 and 4. These machines for this week have a greater number of hours in overtime. This means that we will have an overproduction that will correspond to the production of parts 1 and 2 that were missing for week 11. Now we can see that by having the policy of keeping inventory, we can meet all demand. Therefore, FDC must accept and allow keeping inventory. Thank you very much.